All right, so we'll start with lecture 37. This does begin a new module, so we are now in module 5. This is the last module of this course. And so fortunately, we're not going to cover too much new content material. We're going to review some special procedures in blood bank, talk about some new techniques in blood bank, some things that you can expect in the future. We have one lecture that mentions the production of synthetic blood. We're not there yet, but maybe one day. And talk about some new procedures in blood bank. But lecture 37 is going to concentrate on quality assurance in the blood bank. And I'm sure if you guys remember from hematology, we also talked about quality assurance in the hematology lab, and with every other department of the lab, we do want to think about quality assurance. And remember, quality assurance includes continuous monitoring of the opportunity for improvement. So we are always looking to be able to make improvements, whether that is improving our turnaround times or improving the methods in the lab. How many times do you touch the sample? How can we reduce the time from sample receipt to centrifugation to testing to reporting out results? I would say that's probably the #1 QA project in the lab, is reducing our turnaround times, improving sample collection. If nursing is involved in sample collection and you're getting continuously short draw samples, maybe a QI project would be to re-educate those nurses on sample collection. So those are all quality improvement, which goes into your quality assurance program. So every department will have that. So if you think about what quality assurance means, and if you look up the definition, it's the maintenance of a desired level of quality, all right, in a service or product. And so we want to make sure that we pay attention to every stage involved in providing that product or service, all the way from sample collection to receipt in the lab until testing results. And if you apply that to blood bank, we are thinking about from the time that the products are ordered, the sample is received, the testing is completed, components are set up on your patient. That's even further carried in to transfusing that unit at the patient bedside. So blood bank has to keep all of that in mind when they are developing their quality assurance. Part of a quality improvement project in blood bank might be if you're having an increased number of transfusion reactions. Why is that occurring? Is it something that the nursing staff is doing at the bedside? Is it something that could be developing from the quality of the products? Something. And so that would be a really good quality improvement to help assure quality. So blood bank really, and they even, most blood banks will even, and we'll talk about this, they even have what they call a transfusion committee. So if you guys are ever working in blood bank, you might be selected to serve on that transfusion committee, and you review transfusion reactions, you review your cross-match to transfusion ratio, how much work is the blood bank doing versus how many units are actually being transfused. Those committees will review documentation of that and make suggestions for improvement. So if you guys work in blood bank, that's an opportunity for some additional seniority responsibilities as well. All right, so I mentioned this a little bit. What's the point of quality assurance? So if you think about blood bank, remember blood bank is one of the most heavily regulated departments of the lab because we are providing products for transfusion into our patients. So we are also regulated by the Food and Drug Administration. So the point of blood bank, because we are administering those products to the patient, we want to make sure those products are safe and that the most appropriate component is be given to treat the patient. And we want to make sure, again, that those products are safe and pure. And that means maintaining quality of those products, making sure that, for instance, if you're transfusion platelets, that platelet count is appropriate in that unit. If you're transfusing red cells, that red cell unit has a appropriate hemoglobin level to have the appropriate outcomes in your patient to improve their oxygen carrying capability. And so that's the point of quality insurance, to assure the utmost safety of those products for our patients. Again, one way that we monitor that is through quality assurance, developing quality improvement, performing quality control daily, every 3 months, every 6 months, yearly. And in the next lecture, we're going to talk about some of those quality control requirements. And like earlier, remember, quality assurance includes the entire blood bank department, not only at the hospital blood bank where the component is being transfused, but also the collection facility. We want to make sure that the collection process of those products is also involved in the quality assurance process as well. Again, so think about it. The whole process is included in quality assurance, from the donor collection, infectious disease testing, the ABO-RH, IAT testing, transportation from the donor collection facility to the hospital, all right? And then once at the hospital, all of the compatibility testing that is performed to ensure safety of that product to our patients at the hospital. So if you divide that up, you have pre-transfusion and post-transfusion. And in blood bank, and we'll talk about this too, it's very important that you keep record keeping. And we're going to talk about how long blood bank keeps various records. And then quality control. So if you think about quality assurance, there's really 2 subcategories of quality assurance. You have your quality improvement, where you identify an area of improvement, whether it be reducing your turnaround times, improving sample collection from a specific floor, decreasing the amount of time from ordering products from your donor facility to the receipt of at your hospital. Those are all quality improvement projects, and we're going to talk about how you develop those quality improvement projects and how you develop a plan of action to improve the process. And then there's quality control. So, and we've talked about quality control just like every other department of the lab. We want to make sure that we are maintaining the number one thing in blood bank is temperature control, because we have products that are frozen, we have products that are refrigerated, we have products that are kept at room temperature. So all of those temperatures have to be monitored and maintained continuously, and we'll talk about how blood bank does that. And then reagents as well. We want to make sure that we are doing quality control on our reagents as well. And so like I mentioned, the blood bank is one of the most heavily regulated departments of the lab. And just to give you an idea of some of the regulatory agencies that the blood bank deals with, you have the American Association of Blood Banks, which I've talked about in this course before. It's the AABB. This is a voluntary accreditation. Most of your blood banks will follow guidelines established by the AABB. So they have published guidelines as well. Your hospital will be regulated by the Joint Commission on the Accreditation of Healthcare Organizations. That's at the hospital level. But because blood bank is so involved, and we do provide products for patients that are transfused, usually if your hospital is being inspected by JCO, they will come visit the blood bank as well. And then CAP, the College of American Pathologists, just like our other departments of the lab, blood bank is also regulated by the CAP. If your lab is CAP accredited, CAP will provide proficiencies for you to make sure that not only are your testing methodologies in place and appropriate, but also to make sure that the techs that are performing the testing are competent as well. And we'll talk a little bit about competency versus proficiency. And then the Food and Drug Administration, all right? So this is the one department of the lab that is regulated by the Food and Drug Administration, like I already mentioned. And then another one, this is the big one. It used to be called Healthcare Financing Administration, now known as CMS, Center for Medicare and Medicaid Services. These guys will mandate CLIA, they mandate all of the testing, Medicare and Medicaid, so you guys know what that means. This is the organization that controls reimbursement for our testing. So we want to make sure that we follow all of their guidelines set forth as well, because we want to make sure that we are making money for our services and products provided as well. All right, so some things to keep in mind when you think about quality assurance in a blood bank. We always want to have appropriate record keeping, and we're going to go over some of the time requirements for record keeping, as well as standard operating procedures. So for every procedure that is performed in blood bank, you should have a standard operating procedure or an SOP. And we'll talk about the components of that SOP, what must be included. As well as personnel competency documentation. So if you are a new hire, you usually have like a 30-day probationary period where you do your initial competency training. And usually what that involves is you observe somebody doing it and then you do it yourself. And that's how whoever is watching you will check off that, yes, they have watched you perform the task and that you are now competent in that task. And then after your initial, it might be, I think I said 30 days, but you might have a 90-day competency training. After that 90-day competency training, then your competency will have to be done every year. And so that's one way we maintain personnel competency of the scientists that are certified in performing the testing. And that must be documented. When those accrediting agencies come in for inspection, they will do random checks. They will pull your personnel files. They will look for documented competency. I actually had this happen when I was in blood bank. I was working and they did a random check of an employee competency and they couldn't find it. Now, we swore up and down that it was performed. Now, what happened to that document? We couldn't prove that competency had been done because they could not find documentation. So we did get cited as deficient in that. So it's very important, once your competency is documented, you might want to keep a record for yourself as well as make sure that it gets into your personnel file too. And so that's one thing that inspectors will always look for is documented proof of competency of the personnel performing the testing. As well as validation of our testing, calibration of our equipment, all preventative maintenance must be documented as well. And then proficiency testing, if you do, if you're accredited by CAP, they will send you, I think it's quarterly proficiency testing. And usually the way they do that is they will rotate through each technologist. So one technologist might have to do the ABORH competency or proficiency testing. The next person might have to do a titer. The next person might have to perform a fetal screen. And those proficiency testing samples, they are created to mimic what a patient sample would be like. So you treat them just like you do a patient. You perform all of your routine testing just like you would treat a patient sample. So if your facility doesn't perform titers, then you would work it up to the point, let's say if they tell you that it's a pregnant female with anti-D, so you identify the anti-D, but your facility does not routinely perform titers, you would send it out, then that is as far as you take the testing. You do not perform any testing on those proficiency samples that you do not have procedures for or that you do not routinely perform. At that point, you would say, I've done everything I can do in my facility. We would send it out from that point, all right? Those inspection agencies, CAP, they will they will cite you if you do any testing that is not included in your SOP or done on a routine basis. So if you're at a very small rural area hospital and you guys don't do complex antibody workups and you get a CAP sample that has a complex antibody, you would do as much as you could. And then on your form, you would say, recommend send out from this point on. okay? That's what a lot of people might not understand. And so you want to make sure that for whatever you do, patient testing, proficiency sample testing, you have a SOP in place, all right? And don't veer from that SOP. Supplier qualification, you want to make sure that all of your vendors for reagents, all of your donor products come from a reliable source, and you want to make sure that you have a contract with your donor provider. Error management, so in the event errors are made in blood bank, how did that error occur? How can we prevent it from happening again? And then quality improvement, how can we improve the process control, label control, and internal auditing. All right, so one of the main things about quality assurance is in blood bank record keeping, and I have told you guys this before. If it isn't written down, it didn't happen. All right, so that includes if you are performing quality control and you don't document it, then it did not happen for that day. So every patient sample that was tested and quality control was not documented, once it's realized that quality control wasn't documented, all of that testing sample has to be repeated to ensure that the reagents were working appropriately that day. All right. Now, blood bank, if you are working in a blood bank that has instrumentation, a lot of times the instrument will keep an internal log of quality control. And so usually, in my experience from blood bank, you could access the instrument's internal log of quality control, but we also kept a hard copy of quality control as well. So if somebody forgot to write it down themselves, we could always go back into the instrument and say, okay, it was done. The tech that did it to make sure that they record it. And so that's one good thing about automation and the internal log of quality control. That's another way to keep it done too. And because in blood bank, our testing is considered part of that patient's permanent record. So in the event that you do not have a blood bank management system, an electronic system, and you are still using paper data sheets, you want to make sure that you use the appropriate data sheets, the official data sheets. Don't just write your results on a scrap piece of paper. It has to be an official data sheet. A lot of times you'll see now most blood banks have an associated management system in the computer where they enter the patient results. Truth tables are built in where you enter your results and then you provide the interpretation and the computer will agree with you. If for some reason there's a discrepancy between the front and back type, or a discrepancy between maybe your patient has a historical record on file and then the type that you're getting now is different, the computer will not accept your results. It's going to flag you and say, this does not match, and we have to figure out why it doesn't match. And then I've told you guys too about making corrections. So this is the appropriate way. All right, do not scribble in blood bank. All right, don't do the squiggly line through, completely black it out. In blood bank, we always want to use black or blue ink, no pencil, no whiteout, no red. All right. And then when you have a correction, simply draw the line through, make the correction, initial and date. Okay, that's the appropriate way on official documents to make a correction. Notice they didn't cross out the whole thing. So initially they said the patient was AB, but then they realized the patient was truly O. Notice they only crossed out the AB part. They didn't cross out the whole thing. All right, so just where the error occurred. And like I mentioned, blue or black ink, all right, no pencil, definitely no whiteout in blood bank, never use whiteout. It's very important, and the reason I say never use whiteout is because mistakes are going to happen, and so we don't want to cover up mistakes. And so even if you are entering your results into the electronic record system and a mistake is made, you have to acknowledge the original mistake, all right? And so when we are correcting, let's say it's a patient's ABO, we will issue a corrected patient result. It will have the wrong result, and then it will have the correct result, and clinicians will see that. And so it's just very important that we don't want to hide those mistakes. We don't want to cover up those mistakes. We want to be very upfront and say, hey, you know what? I initially entered an IAT of negative when indeed it is positive. So I have to go back and change my results and create a corrective result as well. All right. So in BloodBank, we pay very close attention to that. We want to be very upfront with our mistakes and make sure that we create a corrective report. And in BloodBank too, it's very important, especially if you have maybe if you don't have a management system computerized, or if that computer system goes down and so you're in downtime and we go back to manually recording on data sheet, it's very important not to use ditto marks, okay? In BloodBank, we don't want to use ditto marks, meaning that you carry from one line to the next. You want to make sure that you're very detailed and that you write out everything on the different line, okay? So no ditto marks. Part of the quality assurance program ensures compliance with the good manufacturing practices. And so that's your GMP, that's good manufacturing practices. And the reason that's so important as BloodBank is because we are providing these products to our patients. We want to make sure they're safe. And so we want to follow all good manufacturing practices. We want to make sure that we follow all the standard operating procedures. And it's okay if you have to pull out that standard operating procedure. Look in the manual, look it up. And in BloodBank too, you'll also, for each reagent that we use, we will also have package inserts that we will reference quite a bit. And there's no shame. When I was in BloodBank, even after many years, I still had to reference the SOP. How long is that incubation time? How do I wash a red cell again? Because one thing in BloodBank, washing red cells, we don't do that on a daily basis. So if you were ever preparing a unit for a neonatal exchange and it needed to be washed, there, and I want to provide a demonstration for you guys on how to do a washing of a unit so you guys see that. The instrument has very many settings, very many dials, a lot of tubing, and so I always pulled out the SOP on that just to make sure that I had everything right. So there's no shame in referencing the procedure manual. It's real easy now. A lot of labs will have it on your computer desktop. So you'll have a digital copy there. You just open it up and then you can search exactly what you're looking for. And even so, in your SOP on antigen typing, especially for those antisera, whether you're doing RH, KEL, Duffy A, Duffy B, some are initial span and read, some involve a room temperature incubation, some involve following all the way through the AHG phase of testing. So it's very important that you reference your package insert on those as well, making sure that you follow the appropriate testing recommended by the manufacturer. Part of QA as well is development and review of training. All right, so maintaining your testing personnel competency. Also, in BloodBank, anytime there is an investigation of product recalls, whether that be reagent or maybe your donor facility contacts you and say, hey, you have a unit that was sent to you 2 weeks ago. We need to recall that unit. Can you give us the disposition of that unit? Is it still in your inventory? If so, pull it and discard it. If not, who was transfused? And so that's another reason document control is so important, to make sure that we can do those look backs on those units, as well as if your patient was transfused, we have to notify that patient that they were transfused, whatever the reason might be. Maybe that donor popped up to be infectious disease tested, or infectious disease positive. And so that would be another part of our QA program. And in my experience in BloodBank, each BloodBank will have a QA officer who monitors all of these things on a daily basis. Like, this is all they do. do product recalls, they do unit dispositions, they make sure everybody is trained, they make sure quality control is performed and documented. They do a lot of document review, updating of standard operating procedures. So now whether you have a specific QA person, like that's their job, or that is passed on to a technologist as an additional senior level responsibility, depending on the structure and the staffing of your blood bank. So just some characteristics of good manufacturing practices. We want to make sure that we have those SOPs in place for every procedure that blood bank does. And then the employees must read those SOPs annually. So every year that you're employed in the blood bank, you will have to read every SOP. And I will say, in my experience with blood bank, our procedure manuals, we had like 5 3-inch binders full of standard operating procedures. And yes, we had to read all 5 every year. And then you'll have to sign the front of that standard operating procedure indicated that you have read, you know where to access those standard operating procedures. You don't have to have them memorized by any means, but you know you've read them, you know where to access them, and that you will perform them on all of your patient testing. Record keeping, we want to make sure that each person that is performing the testing is qualified and that they are able to meet their job description. We want to make sure that you have a proper facility. So your atmosphere that you're working in, we want to make sure it is safe and that the equipment is well maintained to allow you to perform your testing. And then all of our equipment, of course, must be validated. And preventative maintenance followed, as well as quality control. In your, I mentioned the quality assurance officer, they will be responsible for performing those routine audits. They will go in and like spot check the quality control, documentation, making sure that if you have instrumentation that it's documented on the instrument as well as on the internal log that QC was indeed performed every day. And then your antisera that is used is also performed daily. Okay. Now I say antisera, so like your routine forward and reverse typing, all of that must be QC'd. Now, if you are doing antigen typing, we only perform quality control on antigen typing when indicated. So if you're antigen typing a patient or antigen typing units, you will also need to perform quality control when used, right? So you might have some antisera that you don't use on a daily basis, so days might go by where quality control is not performed. But when you do use that antisera, you must perform quality control and it must be documented. All right, so in blood bank, we pay a lot of attention to record keeping. All right, and so the variability, the time of how long we keep these records vary from 5 years, 10 years, or forever, okay? And one thing that you can think about forever is if you have a patient who has an ABO discrepancy or you identify an antibody, that is considered part of their permanent record that must be maintained in the blood bank forever. And most oftentimes you're going to enter that in the computer, as well as if they have an antibody, we will create what we call an antibody card. And so anytime you get that sample from that patient that has a previously identified antibody, we will always pull that antibody card out, and it has a running log on it, and you can record the testing that you do on that current sample. Because remember the importance of that, why we always want to keep a forever record. If the patient has an antibody, we must honor that antibody by providing antigen negative blood, even if that antibody titer is at undetectable levels in your current testing. Okay, so that's why if your patient has an antibody, that is a permanent record in blood bank. We will always keep that. As well as if you think about on the donor collection side, they will also keep records as well. They keep previous donor histories, previous infectious disease testing. And so in your textbook, there are some tables that kind of outline when and how long you keep documents. So if you think about blood donor centers, anytime a donor has been placed on a permanent deferral, that is a permanent record. We want to make sure that we are able to identify that donor in the event he tries to come back and donate again. All right, so we always want to keep a permanent record of infectious disease if they've had a positive test or if they've been placed on a permanent deferral. Maybe they tried to donate and they had obvious needle marks on their arm. They're an obvious IV drug user. Okay, that would be documented. Therefore, the patient is a permanent deferral. Okay, that's a indefinite record keeping forever. And then here's some, usually in blood bank, the most common length of time for document record keeping is 10 years. Right, and so there's several 10-year requirements here on the donor collection side. And I talked a little bit earlier about final disposition. That final disposition of each unit must be kept for 10 years. So in the event a look back happens from 5 years ago, we want to be able to look up, okay, where did that unit go? Which hospital was the receiving unit from that donor? And then what's the final disposition of that unit? Who was the recipient? Was it discarded? So that's what I mean by disposition. Was it transfused? Was it discarded? That's the disposition of the unit. All right, so on the blood bank side, at the transfusing hospital, like I mentioned earlier, it's very important that you guys recognize that. That might be a potentially very good board of certification exam if a patient is identified with an antibody or an ABO discrepancy. That is a forever document, okay? Blood bank must have a permanent record of that. And then for 10 years, again, the final disposition of unit. So what happened to that unit once it was received at the hospital, and then look backs. So we must be able to, again, go back 10 years and look and see what happened to that unit. And notice there are some 5-year requirements. All of our patient requests most oftentimes are received electronically now. Used to, we would get paper requests. A paper requisition would come with the sample, and that paper requisition would have the order on it. And so we would have to keep that for 5 years. So now with the electronic record, we want to make sure that we can still access previous orders for at least 5 years, okay? All right, so let's talk a little bit about the procedure manual and what all must be included in that standard operating procedure. A good way to think about that is somebody with no previous training could walk in, read that procedure manual, and adequately perform that test. All right, that's how detailed that standard operating procedure should be. Now, they might not know what they're doing, of course, but they should be able to follow that procedure. And so the Clinical Laboratory Standard Institute, which is CLSI, they provide standards for all laboratory procedures. And so they provide some guidelines on what should be included in your standard operating procedure. So as you guys start working in the lab, your lab will probably heavily rely and follow the guidelines by CLSI. And again, that SOP will be reviewed and signed by the laboratory director or your medical director, and will be reviewed and signed annually by all testing personnel. Or if there are any implemented changes to that SOP, that also has to be reviewed and signed by all testing personnel. Whether that be, for instance, when I was in blood bank, we had a fetal screen kit change. The manufacturer made a change in the incubation times. And so when the manufacturer, our vendor, let us know about that change, we had to update our SOP. At that time, the updated SOP was posted for all personnel to read and acknowledge that they were aware of the change. And then there's a specific date that that procedure goes into place, right? So Yearly, those procedures have to be reviewed, and if there's any change, that will result in an additional review as well by all testing personnel. I want you guys to understand that you can't just change a SOP. It has to go through the process. Usually a change in the SOP has to be approved by the medical director, and then somebody will officially write up the change in the procedure. And that's an additional what's the seniority responsibility. So you could be involved in writing SOPs. Make sure you document that, include that on your resume, because that's hiring officials are highly regarded if you have been involved in writing SOPs. And so that formal process, once it's approved by the medical director, then all testing personnel must be made aware of it. And then again, it'll have that go live date, if you will. And I mentioned too, package inserts. I cannot tell you guys how many package inserts BloodBank will have. So usually you'll have your 5 binders of standard operating procedure, but then you'll also have another binder where all package inserts are kept. And when I say package inserts, what that is when you receive a new reagent, it has a package insert, and that package insert has the testing principle of that reagent, what's included in the manufacturing process of that reagent, and the recommended testing procedure. So you want to follow that package insert testing procedure. You want to make sure it aligns with your SOP as well. And it might even be that your SOP states, please reference package insert for testing procedure. Okay. And that's just to make sure, let's say, for instance, an example of that, when I was in BloodBank, we had our RH antisera, so big C, little c, big E, and little e. It used to have a 15-minute incubation at 37 degrees in order for the antigen antibody complex to occur. However, the manufacturers changed that, and then it was a 15-minute incubation at room temperature. Okay, so our incubation went from 37 degrees to room temperature because of the incorporation of monoclonal antibodies in the manufacturing process. So with that being said, our SOP had to be updated and everybody had to be made aware of the change. So those are some things that might happen. And that's why package inserts are always so important. And usually the manufacturer will let you know if a change has happened. And on that package insert, there's what we call a revision date. So if the revision date is the same as your previous package insert, you don't have to make any changes, right? So if that revision date updates, then you need to put that new package insert into your binder, okay? And one thing you guys need to be aware of too is not only knowing how to access these SOPs, but in the event that you are ever inspected, the inspector might want to know if you know how to access those SOPs, and not only know that you know how to access them, but that you know how to follow them. And so they will actually watch you perform patient testing, donor testing, whatever it might be, and they will have the SOP for reference, and then they will watch you. So that's why it's very important never to veer from your SOP. Okay, that could result in a site deficiency. All right, so what should be in that SOP? We always want to have a title. Again, you want to have the principle of the test. All right, so what's the testing methodology? What's your end goal? What are you trying to achieve? Specimen requirements. All right, what reagents are going to be used? Instrument calibration, step-by-step instructions, controls. What is used for your positive control? What is used for your negative? And then what constitute a positive control? Is it any type of agglutination? And should the test include a microscopic examination as well? And then expected values, method limitations, method validation, reference. Where did the principle come from? Where did the steps come from? Again, that's where your package insert would be listed. The effective date and review schedule. And then the author of the SOP will be listed on there as well. If you guys think about what your lab manual looks like, it follows this guideline as well. It has a title, all the principle of the test is listed. You have your required equipment, you have your specimen that's required. Some SOPs might not even have your lab manual for sure, probably doesn't have instrumentation and calibration details, probably doesn't go that specific, but you could include that in your SOP. Another part of the quality assurance, transfusion and utilization committee. I mentioned this briefly earlier. Every blood bank will have a transfusion committee, and it is usually comprised of a few testing personnel that are located in the blood bank, the pathologist, nursing representative, and a physician. So the physician is involved in ordering the products, the nurses is involved in transfusing those products. And so what this committee does is it will review certain topics related to blood banks. For example, cross-match to transfusion ratio. How many units are we transfusing on patients versus how many are actually being transfused? Are we performing extra work and then that the clinical staff is not deeming as truly necessary? So that's your cross-match to transfusion ratio. Wasted blood. Are we ordering too many products, especially platelets, and then the platelets are not being transfused, and then we are having to discard multiple products at the end of the day, whether that because they're expiring. So then you can look at your ordering process. How many units are you ordering to how many units are actually being used? And not only for platelets, but you could do that with your red cells as well. How many A's do you routinely keep on your shelf? How many O's and B's do you keep on your shelf? And so you always want to pay attention to your inventory usage as well. And then you want to pay attention too, because that varies on the weekends. So you might not transfuse as much on the weekends as you do during the week, depending upon your OR schedule or anything like that. So it varies. And so you want to have somebody who is ordering the inventory able to make those judgment calls. The transfusion committee can also evaluate transfusion requirements. And I've mentioned this before, a lot of hospitals will have a required hematocrit threshold, so or hemoglobin threshold. Maybe if your patient's hemoglobin is 8 grams per deciliter, but the hospital says that's not necessarily a justification for transfusing, not until they get below 6 grams per deciliter of their hemoglobin should they then be transfused. So the transfusion committee can look at those type of requirements and set guidelines forth on that as well. The transfusion committee will also look at any type of transfusion reactions. What caused the transfusion reaction? Was it something that blood bank needs to educate all testing personnel on? Does it involve retraining of an individual? Or is there a new method that needs to be placed to prevent transfusion reactions from happening again? And they will also look at any adverse effects. Was the wrong ABO transfused? How did that happen? How did blood bank let that get by? How did that happen? How can we prevent that in the future? And then was it on the nursing mix-up? So once blood bank issues that unit, was it transfused? Did it go to the wrong patient room? Anything like that. Anytime there's an incident like that, the transfusion committee will get involved. They will review it. And also when there's any type of reportable error like that, that does get reported to the FDA as well. So this committee will be involved in writing up that error report to FDA. And like I mentioned, this committee will make recommendations too on how to improve those processes. How do we prevent errors from happening again? And so part of the quality assurance program is as well performing quality control. How do we know that the reagents we are using are reacting as they should? And so that is why when we do our forward antiserotyping in our reverse cells, we have to perform daily control on those reagents. And then when you are doing special antigen typing, that is when performed as needed or as used, all right? Not necessarily on a daily basis. And again, very important that you document that. So when I was in blood bank, I was in charge of making sure all quality control for reagents was documented and performed. And so it was a huge undertaking because part of your quality control program includes making sure that the reagents work as they should upon receipt. So whether that be your gel cards, whether that be your rare antisera, all of that, when it's received, has to be, quality control has to be tested on each lot number. And so that's a huge undertaking. It pulled me away from patient testing because on the days where we received inventory, I was performing quality control on every new lot number that was received. So if you guys are ever involved in that, quality control has to be done on your blood bank reagents upon receipt and then on the day of testing as well. Expiration dates are very important in blood bank too, especially when you think about your reagents. So usually think about when we do our reverse typing on patients, we're using A cells and B cells. Those usually only have a shelf life of 2 weeks. So about every 2 weeks, blood bank is going to get new A cells and B cells, A2 cells, check cells. Those are coming in about every 2 weeks. Now your antisera has longer expiration dates. Sometimes those even have years, 3 or 4 year expiration dates on the antisera. But for your red cells, they have a very shortened expiration date. So we always pay attention to our expiration dates in blood bank. We do not ever want to use an expired reagent that has already expired. However, with that being said, I'm going to blow your mind here. There are some rare antiseras that we don't use very much. Let's say if your lab has anti-chelano, right, so little k in the Kell family, or what's another one? Maybe they have CW reagent. Okay, those are very rare. You probably will not use them before they expire. The FDA and AABB are in agreement that if you have rare antisera that has expired, but your controls still work, you can use that special antisera, okay? Your controls have to work. So you have to have a positive and a negative to indicate that that antisera does indeed still have the capabilities of detecting that antigen, okay? That is the only exception where you can use outdated reagents in blood bank. Does that make sense to everybody? And so, but it has to be documented, right, that you performed controls. So this is just an example of what your reagent receipt log would look like. So you would receive your antisera to have a positive and a negative control for anti-D. You could run it with screening cells 1. Usually screening cell 1 is D positive. Of course, your A1 cells would be D negative, and then your screening cell 2. And then we will QC our blood bank saline to make sure that it is not contaminated and causing false positive results. So you record the lot number, the expiration date, and your results. So if you were to mix saline with B cells, your expected result would be a negative reaction there because there should be nothing in that saline for B cells to react with. And then here's your anti-A with A1 cells. Of course, that would result in a 4+ reaction. Your anti-B with B cells would also result in a 4+ reaction. A, B, and with A1 cells and B cells should also result in a 4+ reaction. So the point of doing QC upon receipt is that the reagent is reacting as it should, all right? All right, so in this lecture, we've talked about quality assurance. We've talked about quality assurance in blood bank being used to make sure that we are providing the utmost safest products for our patients, and to make sure that we are monitoring the pre-transfusion as well as the testing that's performed in the blood bank, and then as well as post-transfusion, just to make sure that the product is safe and that the transfusion results in the least amount of adverse effects for the patient. And that quality assurance, remember, includes quality improvement and quality control as well. All right, so that's lecture 37. I think what I'll do is I'll go straight into 38, and this will be included on the same recording. All right, so lecture 38 actually continues on with quality assurance. We're going to be talking about timing. How often is that quality control performed in blood bank? All right, so the FDA does mandate that equipment performance be monitored, okay? So that there's some daily quality control that needs to be performed. There's some monthly, there's some quarterly, and then there's some semi-annually and annually. All right, so timing of all of this is very important, and it needs to be well documented. So we mentioned in the previous lecture that each day of use, you have to perform your routine antisera quality control, and it must be documented, as well as temperature in blood bank is huge. Everything in blood bank is very temperature related. We do not want our products to ever get outside of the desired temperature. We do not want our reagents to get outside of their required storage temperatures. That is why temperature recording in blood bank, what happens most often is you have a electronic recorder that monitors it 24/7. It's continuously monitoring it. If you do not have a electronic temperature monitor, you have to monitor the temperature, whether it be a refrigerator, freezer, or your platelet rotator. It has to be manually checked every 4 hours. Okay, if you do not have that continuous 24-hour electronic temperature recorder. With that being said, and do I have a picture of what it looks like? I don't. I will post one. I will post a picture of what the electronic recorder, it's these little charts. They're in a circular motion, and they have to be changed out weekly. And so it has 7 days on there, and there's this little arm, and it usually occurs at the top of the refrigerators and freezers. It could be at the bottom, but at this little arm, and it's kind of like a seismograph. It continuously monitors the temperature, and if at any time that temperature varies, then you'll have a spike. That arm is going to go out. All right, and so usually if your refrigerator, let's say, gets out of that range, all right, so 1 to 6 degrees, if your refrigerator ever gets above 6 degrees and stays that way for greater than 4 hours, all of the products, all of the reagents must be moved outside of that refrigerator. They must be relocated, okay? And so that's why temperature control in blood bank is so important. And if at any time, let's say we had this happen when I was in blood bank, we had an older refrigerator that continuously, and usually these refrigerators, freezers, the platelet agitator has audible alarms. So anytime it gets outside of the temperature, it's going to alarm, and you have to investigate why it's outside of temperature. We had an older refrigerator. It always had to have refrigerant added to it in order for it to control the temperature. And so it would alarm, and anytime that we reset the alarm and it kept getting increased temperature and stayed out above 6 degrees, for an extended period of time, we had to move everything out of that refrigerator, right? Whether it be products or reagents, right? So anytime that you move products and your refrigerator is not maintaining temperature, you have to develop a plan of action. And so that has to be documented. So on, what's today? Today's on April 13th, my refrigerator jumped up to 8 degrees for an extended period of time. My plan of action included relocating all of the products or reagent to another refrigerator, and biomedical engineering was called to investigate why our refrigerator is not maintaining temperature. Okay. Also, something that happened in BloodBank for us is if you were doing inventory and continuously opening and closing the door, that would also cause the refrigerator to lose its temperature. Now, that is a temporary thing, right? So it should be able to lower that temperature back once the door remains closed. That situation does not warrant moving the products, all right? This is only if your temperature is above that 6 degrees for refrigeration for an extended period of time, all right? I mean, we have to fix why it's not, the refrigerator's not controlling the temperature. And so usually monitoring this temperature, usually you'll have a actual thermometer on the inside as well as the electronic monitoring thermometer as well. So usually on a daily basis, once a day, usually we always did it, whoever was the first one to arrive in the mornings went around and checked the temperature of each of the refrigerators, freezers, platelet, and ambient temperature. So your room temperature as well has to be monitored. That must be recorded daily, all right, as well as those continuous charts, the 24/7 monitoring of the temperature. Okay. Making myself a note to post a picture of what that chart looks like for you guys so you'll know. Peyton says there might be one on the previous. Oh, perfect. Yes, here. This is what it looks like. All right, so this is what your chart would look like. Here's that little arm I was talking about that continuously monitors. So here's your temperature range. If this was a refrigerator, it would be 1 to 4, 1 to 6 degrees. Anytime that arm gets outside of that temperature range, number 1, it's going to alarm, and number 2, if it stays out of range, then you would have to document your corrective action. Okay, and so if you take, this is it here, which if you look in the picture of the actual blood bank, I don't know if that's a refrigerator or must be a refrigerator. That's where it is right there in that upper right corner right there. So that's what it looks like. This is not a very good picture, black and white. I'll try to post a better one as well. If you work in a blood bank that uses refrigerated centrifuge, not only do you have to monitor the temperature of that centrifuge, but you also will have to perform your, use a tachometer to monitor the RPMs of that centrifuge as well. If you guys are involved in the blood bank and you use a blood container scale, whether you be on the donor collection side or you're involved in using weight to make neonatal satellite bags, and you use a scale for that, that scale must be calibrated as well, all right, to make sure that it is using the, giving you the appropriate weight and the amount of blood. Your water bath and dry heat blocks, again, those temperatures must be regulated and documented daily, all right? So once a day, whoever's checking your temperatures of the refrigerators, freezers, and platelets will also check the temperature of your heat block. RH view box, this is if you guys are still doing, so all of the testing that you guys have done in the lab so far has been tube testing or gel testing. We do not use the RH view boxes. The RH view boxes, if you are ever involved in slide agglutination reading, you can put your slides on an RH view box. It has a heat block on it, as well as a light behind it to help view the agglutination. So those RH view boxes, if you are using slide testing, then you would use those, and then the temperature must be monitored on those as well. I highly doubt, I do not know of any blood bank that still uses slide testing, so I doubt you guys will ever see an RH view box. And then again, don't forget to record all of your temperature documentation. And if your temperature anytime it varies, we must develop that corrective action. Was the products removed? Did we need refrigerant? And then here's another very important thing. Once your, let's say it's a refrigerator, whatever it might be, or freezer, goes out of temperature and stays out of temperature, and you have to move products, once you fix that cooler, it has to maintain its temperature for 24 hours before you can move product back into it, right? And so that must be documented as well, that refrigerator, freezer maintained its temperature for 24 hours before it went back into use. And so there's some other maintenance that must be done. Monthly, your electronic thermometers must be calibrated. So remember, I mentioned in your refrigerators and freezers, you might have additional thermometers. Those must be calibrated, especially if they have a digital readout. We want to make sure those are calibrated monthly. And then every 6 months, your RPMs on your centrifuges must be calibrated with a tachometer. So we want to make sure the RPMs that is actually reading on the instrument matches. We want to make sure that it's usually at 3,400 RPMs, and that's every 6 months. And then our pipettes must be calibrated every 6 months. And depending on where you work, those pipettes might be sent out to a third-party vendor that does calibration for you, or if you have a internal biomedical engineering that can perform those calibrations for you, or if you're involved in calibration, you could do your own pipette calibration. Just make sure that it's documented and performed every 6 months. So we always want to maintain our equipment as well, and you think about equipment, centrifuges in blood bank, as well as cell washers. So for your cell washers, I believe it's quarterly. Every 3 months, you want to check the RPMs of your cell washer. You want to make sure that the cell washer, you will do daily. If you think about a cell washer, you guys remember it adds saline into each of the tubes. So you want to make sure that the volume of saline being added is appropriate, and that is done daily. And so you will use a graduated cylinder. It should be about 40 mils that is delivered during one wash cycle. So you will add a graduated cylinder into right under the spout where the saline comes out. And then push the wash, let it go through one delivery of saline, and it should be about 35 to 40 mils of saline. If it's not, then on your tubing that goes into the saline box is a little dial that you can adjust, and you can make it deliver a lower amount or greater amount, right? So that's another thing in blood bank that we always want to maintain as well. And then you also want to make sure that the delivery of saline and the centrifugation does result in an appropriate cell button. And so we don't want that process to wash away our cells, and we don't want it to not adequately wash enough. So usually whatever you're doing your washing for, and whatever your blood bank is approved to perform, whether you're doing your week D testing, whether you're doing your DAT testing, whatever you're using the cell washer for, you want to perform a positive and negative control, and that would be every 3 months, just to make sure that you're measuring your cell button achievement from after cell washing. So in blood bank, anytime you receive new equipment, it must be calibrated before it's brought into use. And then anytime you move it, it must be recalibrated as well as the normal calibration every 6 months. All right. And that just involves, you know, checking your RPMs with the tachometer every 6 months. And then again, documenting that as well. So in blood bank, you can imagine we have a lot of QC documentation that must be reviewed. So your QA officer will review it, as well as the medical director of the blood bank will also review these documents, just to make sure that proper quality control, preventative maintenance, everything is performed. We also want to maintain quality assurance on our products to make sure each component is safe and meets the required outcome. And that includes making sure the correct concentration, whether if it's red cells, the appropriate hemoglobin and hematocrit is achieved. If it's your platelets, make sure each unit has the appropriate platelet count. We want to make sure the pH is maintained of those units, and then also the temperature is maintained of those units. Now, I want you guys to understand, we don't QC each product. That would be very time consuming. So we usually do random checks. So 3 or 4 components a month must meet these requirements. And oftentimes this is done at the supplier site. So not a lot of hospitals will do this routine check, a random check. So some requirements for the products, platelets must be tested for the adequate numbers of platelets. Each unit should have about 45 to 65 mils per unit, and that, remember, your required platelet count per unit should be 5.5 times 10 to the 10th. And then we want our pH no less than 6. And with those platelet requirements, there will be a small amount of plasma in those platelets, but we don't want too much plasma, and so we want to make sure that that plasma falls about 50 mils or less. And then again, the temperature must be checked manually every 4 hours or once a day and recorded, or will be checked once a day manually. And then if you do not have a automated 24/7 monitor, it must be checked every 4 hours. Personnel. So like I mentioned earlier, there must be a job description for each level of staffing. So if you are a technologist that is involved in performing patient testing, you want to make sure that you are able to function according to your job description. You want to make sure that you're appropriately qualified to perform the job description. And then we talked a little bit about this in the previous lecture, having written documentation. So that 90-day training period where you're doing your initial competency training. And then after that, your yearly competency training, again, that must be documented. There's different levels of competency. Some people in blood bank, we used to always say, watch one, do one, trained. But sometimes some people might have more strict, they might actually have you perform 50 type-in screens on patients before you're officially considered competent. So it just varies on your staffing and your level of competency. As well as you want to make sure you're proficient in the blood bank computer system. So you want to make sure that you know how to enter patient results, you know how to look up patient history, you want to know how to access your units that are in inventory and whatever special attributes are associated with that unit. Is that unit already irradiated? Is that unit already in cross-match status? Which means it's attached to a patient, cross-match has already been performed, it's ready for transfusion. Is that product leukodepleted? Has the plasma already been thawed? And so being able to look up those products in your computer system. So there might be some online training modules on how to do your blood bank management system. And so your competency, again, That's your training. It will be documented yearly. And again, the way they document that, usually somebody observes you doing it, and you'll have a checklist. I believe I have a picture. So here's here's an example of a competency. So you were able to perform the IAT, you used the appropriate sample, you appropriately labeled your tubes, you made your correct cell suspension, you incubated your tubes for the appropriate time, you centrifuge for the appropriate time, you were able to grade your agglutination, interpret positives versus negatives, and then make your patient's IAT interpretation. So did you perform it correctly? Yes. And if you did not perform it correctly, what's the corrective action? Retraining, anything like that. And then proficiency testing, like I mentioned, if your lab is accredited by CAP, they will send out regular proficiency testing. That just makes sure that not only are the techs trained, but they are able to follow the procedure, they are able to obtain the appropriate results. And so when you receive these proficiency samples, you do not know what the results are supposed to be. So you do your testing, you report your results, and then CAP gives you a report. Were your results adequate, appropriate? And like I mentioned, those proficiencies are usually rotated through the staff. We want to make sure all of the staff are involved in proficiency testing. So that proficiency testing, again, sent from an outside vendor. The most common one is College of American Pathologists, CAP. There are other options. There is the American Proficiency Institute, API, that might provide proficiency for your lab. And again, these proficiency samples evaluate technical skills of your staff, as well as making sure that your testing processes are effective as well. All right. So if you're identifying an antibody, you go through all of the correct actions to be able to correctly identify that antibody. For proficiency testing, so I mentioned you don't know what the results are supposed to be, and you submit those to CAP. For blood bank, you must have a 100% accuracy. And then CAP, if there's any deficiencies, we will work with CAP to resolve any of those deficiencies. So part of the quality assurance program also involves quality improvement. So making sure we are doing things the most appropriate way to achieve the task. And so usually the way quality improvement works is if you identify an issue, you can develop a quality improvement project to improve the process, to fix the problem. So JCO has released 10 steps for quality assurance, quality improvement. Number one, you want to assign responsibility. So usually if you're involved in quality improvement, you want to make sure that you develop a team to address the issue. You want to have all stakeholders involved. And so that means the ones that are receiving the samples, the ones that are involved in testing the samples, the ones that are involved in collecting the samples, the ones that are involved in receiving the results. So usually it's not only in the blood bank, but it's also those that are using blood bank results. Those are all of your stakeholders. You want to identify the most important aspect of care. So what's the issue? Where is the issue occurring? And what's the identified goal? What are we trying to improve here? So if you think about a quality improvement project, you think about identifying the issue, forming your team, all the stakeholders. Then you're going to launch an investigation. You're going to figure out, so let's say maybe it's a specific floor of the hospital that is continuously ordering products but not being transfused. All right, so it's causing blood bank a lot of work and could potentially end up in wasting products. So what is it? Once you realize who is ordering all these products, then you figure out the location. So in your investigation, you identify the specific floor. Once you identify where the issue is, then you can develop a plan of action. How can we resolve this, keep it from happening again? That might be just plain re-educating, holding a training session for all of the nurses on the floor, all of the ordering physicians on the floor. That might be a good QI project to reduce the amount of products that are being wasted. So then your QI team will implement the change, and then you're going to monitor that change for a period of time. Did the situation get better? All right, so that's the ultimate goal of quality improvement. Identify an issue, develop a plan of action to correct the issue, and then make sure that the process did improve. So some common indicators for blood bank, and what we mean by indicators is what's the issue? What's some indicators for a blood bank? All right, so maybe recruitment goals. So maybe blood bank is low staffed right now. They're having a very hard time finding qualified testing personnel. And so recruitment might be an issue. How can we attract more testing personnel to the blood bank? Maybe if you're at a collection facility, the wait time for donors. Maybe they come in for their appointment at 2 o'clock. They have to fill out the donor questionnaire, then they have to go through the physical examination. What's the delay? So one thing that donor centers have done now is they've launched that questionnaire online. So donors can make an appointment. They can complete that donor questionnaire before they even get to the donor center. So once those donors get there, if they pass the questionnaire, they can go straight into the physical examination part to reduce the time for donors, to make sure that we keep our donors coming back so we have adequate donor supply. Labeling errors, percent of transfusions that were autologous, correct use of ROGAM, making sure all of our patients that are transfused have wristbands on, and then turnaround time is usually the #1 quality improvement. How can we reduce the amount of time that our clinicians get the products they need for the patients? So some quality assurance monitors, you can look at the donor process, you can look at the process of components, you can look at time it takes the patient to receive the product, utilization of those products. Are we wasting products? Are the units that are cross-matched actually being transfused? Personnel and accreditation. So some donor collection monitors, donor arm preparation. We want to make sure that we're maintaining that aseptic technique to prevent bacterial contamination. Donor history, physical exam. Again, this has been a change that a lot of donor facilities, the paperwork is done online prior to their scheduled donor appointment. Number of short draws, if you can identify it to a specific unit, maybe that will warrant retraining of the staff on that unit. And donor reactions, so if you're having consistent adverse reactions, what's causing those adverse reactions, and your transfusion committee will pay very close attention to that. Component processing, mislabeled units released. Maybe the unit was irradiated, but it wasn't documented or labeled as irradiated. Hopefully we never have a unit that is labeled as the wrong ABO. That's another reason why when we receive units from the donor facility, the blood bank will reconfirm the ABO-RH. And then inappropriate release of components. Maybe your patient needed volume replacement, so maybe FFP was warranted, but your clinician ordered red cells, or vice versa. You want to make sure that the appropriate component is being ordered for the patient's need. And then again, is it necessary? That's a lot of times why hospitals have implemented quality improvement programs. and developed those hematocrit or hemoglobin thresholds. Well, your patient's hemoglobin is 10 grams per deciliter. They don't need 2 units of red cells, not until they reach that 6 grams per deciliter should they get a unit of red cells. Or your patient's platelet count is 40,000 per microliter. Your hospital does not allow transfusions until the patient reaches 20,000 per microliter. So having those thresholds in place, developed by the Transfusion Committee, a quality improvement project at one time, resulted in those thresholds being developed. You could also monitor, so if you are consistently seeing the same issue, that might warrant a quality improvement product. The number of mislabeled specimens, so if the name or medical record number is consistently not matching, that might warrant a quality improvement project to retrain the phlebotomist or the nursing that are collecting the sample. Or maybe you consistently receive samples from a specific location that does not have adequate volume for testing. So that's resulting in multiple redraws of the patient. That's a really good quality improvement project. How can we make sure these samples have the appropriate amount of volume so we can do our testing without having to have the patient venipuncture multiple times for the same test? Number of corrected reports. Maybe one of our blood bank testing personnel consistently make errors. How frequently does those errors recur? How can we prevent those errors from occur? Maybe they just need retraining on the computer system, or maybe in the way they set up their tubes for interpretation. Maybe that would be a good QI project. Number of service complaints. Usually a really good QI project comes from a complaints, whether that be if you're at a donor facility, maybe your donor says the phlebotomy process took too long, or maybe if you're at a hospital site and the nursing staff consistently complains that it takes too long for them to receive the product. So why is there a delay in them receiving the product? Usually QI projects come from those complaints. And physicians too, especially if they're in a trauma situation and they are wanting O negative uncross matched units of blood and there's a delay in that, what's causing the blood or what's causing the delay? One way that UAMS addressed that issue for access of the ER to have O negative uncross matched units, they implemented, when I was in blood bank, they implemented what was called the blood safe. So there is a refrigerator now in the ER at UAMS that thing but O negative units. I believe they keep 4 O negative units down there. And so that was a result of a QI project. The blood bank and the clinicians in the ER agreed. And so as a result of that QI project, you can imagine all the training that involved on nurses and other patient care clinicians to understand how to adequately document which unit was being taken out of that refrigerator and then which patient was receiving that unit. So it puts a lot of control in the nursing and physicians' hands, product control. So, but they're all O negative, so there should not be any issues there, but that was a result of a quality improvement project. It reduced the amount of responsibility on the lab scientist because we had to stop what we were doing, load a cooler, and then manually deliver 2 O negative units down to the ER and whenever a trauma occurred. So having them direct access reduced the amount of work on blood bank and also reduced the turnaround time for them to be able to get those products to the patient that was a trauma. And so that kind of goes into turnaround time too, where their receipt of the sample and testing of that sample, that's your turnaround time, or the time that it takes the nursing staff to get the product to transfuse the patient. Again, turnaround time is usually your lead indicator for quality improvement products. How can you reduce that time? And then utilization review. Remember, we mentioned that transfusion committee. These are some of the things that they will always review. All data must be compiled into a monthly document, so they're cross-matched to transfusion ratio, the number of transfusion reactions that were reported, what type of reactions according to your patient's symptoms. Did you have a high number of allergic symptoms, such as hives and chills, or did you have an increased number of febrile reactions? How many units did we waste this month? And then how many units were wasted because they expired? They expired before we used them. Then again, if you're ordering too many products and you're expiring and wasting too many products, then you might want to develop a quality improvement project to look at the number of units that are being ordered on a daily basis. Number and percentage of autologous units. So if your hospital is receiving quite a few autologous units, but then they're not being transfused. Indications for transfusion documented in the patient's medical record. Again, you want to make sure that that hemoglobin and hematocrit threshold is met there as well, and that we are given the appropriate component according to your patient's symptoms, whether they need oxygen carrying capabilities, they need platelet products. And then you want to make sure that your patient vitals that are taken during that transfusion and after that transfusion are documented and included as a part of that patient's medical record. That is a part of their permanent patient record. And then the transfusion committee will always look and see if the blood transfusion guidelines were followed. If you have those established thresholds, we want to make sure our patients are only transfused if those thresholds are met. So here's just an example of a monthly quality management document that your transfusion committee would review. As part of the accreditation process, there are some processes that need to be followed as well. Checklists are going to be reviewed. So each of your accrediting bodies will have all of your standards listed. They will have checklists that you must achieve. Most of those are available online. So you want to make sure your quality control is being performed in a appropriate, timely manner, as it should be. And then inspections. So these accrediting bodies, they will do inspections. You can have CAP inspections, you can have FDA inspections, you can have AABB inspections. Usually CAP and AABB will do a joint inspection of the blood banks. So they'll usually be together. And then those inspectors will follow those checklists. And so you want to make sure that your blood bank is doing everything on those checklists to make sure that you don't get any deficiencies cited. And usually, if you are decided a deficiency, a plan of action is corrected. How are you going to fix that deficiency? Usually, you're given a 30-day grace period to submit a plan of action, a corrective action. However, if it's a severe deficiency and you had repeated FDA reportable errors. So if you have consistent FDA reportable errors, FDA is going to start investigating that. And if you have that, and then also that could result in your CMS license revoke. So what happens then? You don't get paid. So that's huge. And then if you're not accredited, then if your hospital is dependent upon blood bank, your hospital cannot function. They won't be able to receive traumas, anything like that. So it's a huge effect. That's why we always want to make sure that we follow the standards set forth by our accrediting bodies. All right, so in this lecture, we talked a little bit more about quality insurance, including the proper documentation of quality control, the timing of performance of that quality control, and then the proper documentation of our temperature in blood bank. That's a huge thing for blood bank, is monitoring our temperature as well as our equipment maintenance. maintenance as well. And then we talked about staff competency and performing proficiency testing. We talked about some really good indicators for quality improvement projects. And then we talked about how the accrediting bodies use those checklists during their inspections. All right, any of you guys that are here have any questions? Okay, well, I will see you guys tomorrow for lecture 39.